Hello, everyone. In this talk, I will talk about blockchain-enabled federated learning. My name is Sara Rouhani from University of Manitoba. And in this talk, I specifically talk about one of our recent studies that proposes a sharding mechanism for blockchain-based federated learning. So I will start with a brief introduction about federated learning technique, and then I will explain how blockchain can contribute to the federated learning to enhance the security among other benefits. And then I will explain how we can deploy a sharding mechanism to increase the scalability of the system. I will show you the evaluation results, and I will wrap up this talk with a hint on future works. So federated learning is a machine learning technique that pushes training to the edge devices. In a typical machine learning system, a data set that includes users' raw data reside in a server, in a machine learning server to be used for model training. So it requires that to move and transfer users' raw data into a machine learning server. But federated learning allows us to keep the data at the edge devices and then train the model locally at the edge devices, and only the model updates will be transferred to the federated server for generating the global model. So in this way, it addresses the privacy of the users by keeping their data at their own devices, as well as is distributed the computation that is required for training a machine learning model. So it starts with this step that a federated server generates an initial model, and then it selects a subset of edge devices to participate in the learning process. So those devices will download the initial model, and then they will train the model using their own data, and they only will upload the model updates and training updates to the federated server. And then the federated server will aggregate all the model updates, generate a new model, and again, this model will be downloaded by the edge devices. So we can see that it includes multiple rounds of training until the convergence happens. So it's a good and important steps toward decentralization of a learning process, but the federated learning by its own is dependent on a centralized server to collect the training updates and generate the global model. So it is vulnerable to problems that comes from the centralized system, and it also doesn't have any procedure to verify the model updates to generate the global model. So it is vulnerable to like the data poisoning attacks, and it doesn't have any process to verify the accuracy of global model that is generated by individual updates. So we can use blockchain to address these problems. So we can use blockchain to replace the centralized server. We can use the smart contracts to aggregate the model updates, and we can use the consensus mechanism in the blockchain to verify the model updates before adding to the ledger. It might not be efficient to involve all the edge devices in the federated learning consensus process. And a study suggested another consensus mechanism called committee consensus that involve a subset of nodes. So a committee will be built at each round from a randomly selected nodes, and this subset of nodes will be responsible to verifying the model updates and aggregating them to the blockchain. And every round, these committee members will change randomly. So with the blockchain, we can store like the model training metadata that can aggregate it and generate the global model, as well as the history of the model updates contributed by various edge devices. Sharding is a technique that divides the network into multiple smaller pieces. So each shard can include a subset of peers, and they can verify and be involved in the transaction processing in parallel. So in this way, we can achieve scalability. So in this study, we have decided to implement a sharding mechanism for federated learning and evaluate the implementation. Two smart contracts have been employed for implementing the sharding mechanism. One of them is a main chain smart contracts, or chain code. It's the term that used in Hyperledger Fabric for the chain code. So main chain is a smart contract that is responsible for managing shards. It generates shards. It's manage the collaborations between shards and communication between shards. Another smart contracts is models smart contracts that deployed to each shard separately. So it is responsible for verifying the model updates, aggregating the model updates, and store them on the ledger. For evaluating the system, we use Hyperledger Caliper, which is a benchmarking tool, and we used it for collecting performance evaluation results. The system has been implemented using Hyperledger Fabric. It's a well-known permission blockchain platform, and each Fabric peer worker is installed the PyTorch for the federated learning library. So in this graph, you can see how the system is behaving in response of adding more shards to the system. You can see that by the system throughput is increasing linearly by adding more shards to the system. And here we wanted to see that what is the maximum number of transactions that our system can handle, and what is our system limit. So we increased the send rate and we tested the system with multiple shards. So you can see that by adding more shards, still the throughput of the system is increasing, and the average latency of the system is decreasing. So for the future direction, we are focusing on two more projects. One of them is a MyTax project with the collaboration with Theory Mesh company. So in this project, we are utilizing federated learning to enhance the collaboration between multiple parties for the agri-food supply chain application. This is an application that specifically requires collaboration between multiple parties involved in different components of the system, and many of them prefer to keep their own data at their own local systems. So with utilizing the federated learning, we can achieve a system that can extract knowledge from individual parties that involve in the system, and at the same time we can maintain the data at the local devices contributed by independent parties. Another focus of this project is privacy preserving for our federated learning framework. So with the collaboration of Linux Foundation, it's a project that is supported by Linux Foundation, in particular the Hyperledger internship program. We are working on developing a framework that authorize the individuals who contribute their data for the federated learning through self-sovereign identity platforms. And we are utilizing Hyperledger Iris and with the bundle of package from Hyperledger such as Hyperledger Indy and Hyperledger Ursa to integrate the system with the self-sovereign identity. Thank you for your attention. I will be happy to answer your questions.